Hello students, let's start the last and simplest chapter of this semester, number system and theory of equation. I am saying simplest because you have already studied this at school. We are just revising what we have learned in 8-9 standard. So let's start. This is a number line. Okay, 0, 1, 2, 3, 4, so on till infinity. -1, -2, -3, -4 and so on. Right? So when I say 1, 2, 3, 4 till infinity, that means these are called as natural numbers. Okay? When I include 0 to natural numbers, they are called as whole numbers. Right? And when I include negative numbers to whole numbers, it becomes integers. Correct? These are positive integers. And these are negative integers. Correct? Okay. Now, what are rational numbers? Now, whenever you write fraction or whenever you write a number which is in this form p by q, for example 2 by 3 or 5 by 6 or 7 by 9 or -8 by 10. Okay, whenever you write like this, these are called as rational numbers. It can be negative, it can be positive. Right? Okay. Provided your denominator should not be equal to 0. Okay. If I write 3 by 0, then it is not defined. Okay. So your denominator cannot be a 0. So whenever you are writing numbers like this, then it is called as a rational number. If I write 3 by 3.5, this is also a rational number. So it can be in a fraction form or a decimal form. They all are called as rational number. Is 5 a rational number? Yes, it is also a rational number because 5 can be written like this, 5 by 1. Correct? Okay. So, all the integers are rational numbers, and even fractions or numbers which are in decimal, they are also rational numbers. Right? But there are some numbers which are irrational numbers. What are irrational numbers? So numbers which are neither terminating nor repeating are called as irrational numbers. For example, non-repeating decimals. For example, if I write 5.010020617803004 whatever, and it is keeping on going. So this number is an irrational number because the decimal is not repeating and it is non-terminating. It is never ending. Correct? The decimal is not ending and it is not repeating also. For example, if I write 5.010101, so 01 is recurring, right? So then this becomes a rational number. Okay, because now it is repeating decimal. So This is a rational number. I'll give you a few more examples of irrational number. For example, root 2. Let's see in the calculator what is the value of root 2. So when I write root 2, the answer is 1.414213562371, and it's so on. Okay, so that means root 2 is a irrational number. Similarly, root 3 is also irrational number, 1.732050. So it is keep on going. It is neither terminating nor repeating decimal. So still and again this is a irrational number. Okay. So root 2 is a irrational number. Root 3 is also irrational number. But when I say root 4, what is root 4? 2, right? So root 4 is a rational number. Why root 4 is a rational number? Because the answer is 2. So 2 is a rational number. That's why root 4 is also a rational number. So square root of perfect squares are rational numbers. Okay. If I say root 9, what is root 9? It is 3. So root 9 is a rational number. Okay. But root 2, root 3, root 5, root 6, root 7, root 8, root 10 are all irrational number. Okay, these are irrational numbers. So square root of a perfect square is a rational number. Okay, and square root of any other number is a irrational number. Okay, so let us make a tree diagram out of this. So, and rational number, irrational number together are called as real numbers. Okay, so I'll make a tree diagram from this. Real numbers are divided in two. One is rational and irrational. Okay, irrational number, I have given you the example. Root 2, root 3, 5.100000010234 and so on. This is an example of irrational number. Okay, rational numbers can be divided in two again. Integers and non-integers, which is non-integers. Non-integers are 2 by 5, minus 3 by 6. I'll not write minus 3 by 6. Wait. Minus 3 by 6 is 1 by 2. Yeah, that I can write. Okay, fine. Minus 3 by minus 3 by 5, 4 by 7, minus 4 by 11. These are non-integers. Correct? Or 0.25, 2.75. So these are non-integers. Integers are the numbers which were there in number line. So minus 3, minus 2, minus 1, 0, 1, 2, 3 and so on. Right? These are the integers. Now integers I can write as negative numbers, negative integers, and whole numbers. Okay. Negative integers are -4, -3, -2, -1, right? And whole numbers are 0, 1, 2, 3, 4, 5, so on till infinity. Again, whole numbers can be divided in natural number and 0. Natural numbers are 1, 2, 3, 4, 5, so on till infinity. And 0 is a 0. Correct? Okay. So next, what are even numbers? Even numbers are those numbers which are divisible by 2, right? So 2, 4, 6, 8, 10, 12, even the negative numbers, okay? -2, -4, -6, -8, right? These are the even numbers. Even numbers are those numbers which are divisible by 2. Odd numbers. Odd numbers are those numbers which are not even. Correct? So 1, 3, 5, 7, 9, 11, 13, so on. Right? You can include negative numbers as well. Okay? So even numbers are those numbers which are divisible by 2. Odd numbers are those numbers which are not divisible by 2. Next is prime numbers. So prime numbers are those numbers which are divisible by itself and 1, that's it, and no other number. For example, 2, 3, 5, 7, 9, 11, 13, 17, 19. So these are the numbers which are divisible by itself and by 1, that's it. Right? So these are called as prime numbers. Next is composite numbers. Composite numbers are those numbers which are not prime numbers. For example, 4. 4 is a composite number. Why? Because it is divisible by 2. Right? 2 2s are 4. 6 is a composite number. Why? It is divisible by 3 and 2. Correct? So composite numbers are those numbers which are divisible by other number, or which are multiple of other numbers. Okay? So composite numbers are those numbers which are not prime numbers. Okay? Now let us calculate LCM and HCF. LCM and HCF. What is LCM? This also you have already studied. LCM stands for least common multiple or lowest common multiple. So LCM stands for correct, lowest common multiple. And what is HCF? HCF is highest common factor. Highest common factor. Okay. So let's calculate LCM first. Let's do LCM first. Lowest common multiple. Okay. So there are two methods to calculate LCM. One is prime factorization method and second one is division method. So there are two methods, prime factorization method and division method. So let's solve few sums in prime factorization method. So find my question number 1, find the LCM of find the LCM of 12, 16, 24. We will use prime factorization method. Okay, so you have to find prime factors of these numbers. So 12, 16 and 24. Let's find the prime factors of these numbers. 2 6 are, 2 3 are, 3 1s are. So these are the prime factors. And for 16 it would be 2 8s are, 2 4s are, 2 2s are, 2 1s are. For 24, 2 12s are, 2 6s are 12, 2 3s are 6, 3 1s are. So let us write the prime factors. So prime factors for 12 are 2 into 2 into 2. Or I can say the prime factors of 12 are 2, 2 and 3. Correct? Prime factors of 16 are 2, 2, 2 and 2. Prime factors of 24 are 2, 2, 2 and 3. So these are the prime factors of the given numbers. Now first let us see which all are the common factors. So the common factors are 2, 2, 2. 2 is common in all the three. Correct? So my common factors, no, I'll not write like this. So I'll just write 2. Okay. So I'll write the common factors first. Okay. Now again 2, 2, 2 is common. Right? Okay. Now all the numbers are uncommon, but there are numbers which are common between two numbers. Right? For example, now 3 and 3 is common between 12 and 24. Correct? So I'll write 3. Okay. Then 2 and 2 is common between 16 and 24. So I will write that. Okay. And then finally I will write uncommon number, which is 2. Okay. So let's multiply this. 2 into 2 into 2 into 2 into 3. Mm-hmm. 2 into 2 into 2 into 2 into 3. So it comes to 48. That means 48 is the LCM. Oops. 48 is the LCM for 12, 16 and 24. Okay. Let's solve one more sum using same method. Problem number 2. Find the LCM of 9 and 36. 9 and 36. Let's find the prime factors. 9, 36. Okay. 3 3s are 9, 3 1s are. So the prime factors for 9 is 3 and 3. Let's calculate for 36. 3 12s are 36. 3 4s are 12. 2 2s are 4. And 2 1s are 2. So for 36, the prime factors are 3 into 3 into 2 into 2. The prime factors are 3 3 2 2. Correct? So first let us write the common factors. So the common factors are 3 3 and 3 3. Correct? So that means 3 into 3 is common. Right? And the remaining one. The remaining one means the uncommon one. So 2 and 2 is uncommon. So 2 into 2. So 3 into 3 into 2 into 2. So that is the LCM. This would be the LCM. 3 into 3 into 2 into 2, which comes to 36. So 36 is the LCM for 9 and 36. Okay. Let's solve one more sum. Using same method, find the LCM of 18, 27 and 54. 18, 27, 54. So 18, 27, 54. Okay. 2 9s are 18, right? 3 3s are 9, 3 1s are 3. 27. 2 is not divisible. So 3 9s are, 3 3s are, 3 1s are. Right? 54. 2 2s are 14, 7. Okay. 3 into 9, 3 3s are, 3 1s are. So what are the prime factors of 18? 2, 3, 3 are the prime factors of 18. 3, 3, 3 are the prime factors of 27. 2, 3, 3, 3 are the prime factors of 54. Right? Let us see the common factors. No, 2 is not common. Okay. Okay. So the common factors are 3, 3. Correct? These are the common factors. Okay. So I will write it down. 3 into 3. Okay. Now let's write the common factors which are common between two numbers. The factors which are common. Okay. So 2 and 2 is common here. Okay. So into 2. And 3 is common here. So into 3. So LCM would be 3 into 3 into 2 into 3. 3 into 3 into 2 into 3, which comes to 54. 54. Right? Let's solve the next question. Find the LCM of 25, 40 and 60. I want you all to solve by your own. LCM of 25, 40 and 60. Please solve it by your own. So LCM what you should get is 600. I believe that everybody is getting the correct answer. You can calculate LCM using division method also. Take down the next question. We will solve the next question using division method. Find the LCM of 8 and 14. So while calculating in division method, you have to calculate factors together. Okay. So 2 4s are 8, 2 7s are 14. Okay. 2 2s are 4. Okay, 7 is not divisible by 2, so you will write 7 as it is. Okay, again 2 1s are 2. 7 is not divisible, so write 7 as it is. And then 7 1s are 7. So LCM will be 2 into 2 into 2 into 7. So what you have computed is LCM. When you calculate this, you will get 56. So this is division method. I'll recommend you to calculate in division method. Let's solve the next question. Question number 6. Find the LCM of 20, 24 and 30. 20, 24 and 30. Let us see what are the factors of 20, 24 and 30. So 2 10s are, 2 12s are, 2 15s are. Correct? 2 5s are 10, 2 6s are 12. 15 is not divisible by 2. So I'll write 15 as it is. Then 2 3s are 6. Okay. 2 5 is not divisible. Right? So I'll write 5 and 15 as it is. Then 3 1s are 3, 3 5s are 15. I'll write 5 as it is. Then 5 1s are 5 1s are. I'll write 1 as it is. Okay. So now LCM is 2 into 2 into 2 into 3 into 5. So when you calculate this, it comes to 120. Okay. Let's calculate the next question. I want you all to do it by yourself using division method. Find the LCM of 16, 24 and 36. Please do calculate it yourself. So I hope everybody has got the correct answer. 144. Okay. Now let's solve next question. Now let us solve questions of highest common factor. Okay. How to calculate highest common factor, HCF. How to calculate highest common factor? Again, there are two methods, prime factorization method and division method. First, you will calculate the prime factors and then you mark the common prime factors, and the product of all common factor is the highest common factor. Okay, you have already studied this in 8th, 7th, 8th standard maybe. So, question number 8. Calculate HCF of 8 and 12. How to calculate HCF of 8 and 12? So, prime factor methods, that means you have to first calculate prime factors. Okay. So, 8, the factors of 8 is, prime factors of 8 are Okay. So the prime factors of 8 are 2, 2, 2, and prime factor of 12 are 2, 2 and 3. Okay. So let us mark the common factors. So the common factors are 2 and 2, right? So the HCF would be 2 into 2, which is 4. Okay. Let's solve the next question. There's another way of solving also. I'll just show it to you all, but I want you all to follow this method only. Okay, the another way is, let's see what are the factors of 8. Okay, the factors of 8 are wait, the factors of 8. Okay, what are the factors of 8? Let us see the factors of 8. Okay, 8 into 1 is 8, and 1 are the factors of 8 for sure, right? Because 8 ones are 8, right? Then 4 twos are is 8. So 4 and 2 are also factors of 8. 4 and 2. Correct? 4 twos are or 2 fours are. That's it. Right? So the factors of 8 are 1, 2, 4 and 8. Right? Let's see what are the factors of 12. Factors of 12. So factors of 12, 12 and 1 for sure. Right? Then 6 twos are 12. 6 and 2 are also factors of 12. Right? Okay. Then 4 threes are is also 12. So 4 and 3. So the factors of 12 are 2, 1, 6, 2, 4 and 3. Factors of 8 are 8, 1, 4 and 2. Correct? These are the factors. So let's see what are the common factors. So common factors are 1, 2, 4. Correct? 1, 2, 4. These are the common factor. Correct? Which is the highest common factor? Highest common factor is 4. Right? So HCF is 4. This is also one way of solving. Okay? Okay. Now let's solve the next question. Find the HCF of 20, 30 and 40. 20, 30 and 40 by prime factorization method. Okay. So when I say prime factorization method, you have to calculate all the prime factors. Right? So 20, 30 and 40. Let us calculate the prime factors. 2 into 10, 2 into 5, 5 into 1. 2 into 15, 5 into 3, 3 into 1. 2 into 20, 2 into 10, 2 into 5, 5 into 1. So my prime factors of 20 are 2, 2, 5. Prime factors of 30 are 2, 3, 5. And prime factors of 40 are 2, 2, 2, 5. So let us see which are the common factors. Common between all the three. 2 is common, right? And then 5 is common. That's it. So common has to be the common factors of all the three numbers. So 2 and 5. That means my highest common factor would be 2 into 5, which is 10. Okay. Let's solve the next question. Question number 10. Find the HCF for 47 and 15. So HCF of 47. 47 is a prime number. Okay. So 47 into 1 is 47. It is not divisible by any other number. Okay. 15. So 3 into 5 is 15. 5 into 1. So the factors of 47 is 47 and 1. Factors of 15 is 3 and 5. Right? So nothing is common. When nothing is common, then 1. 1 is the highest common factor. Okay? So I'll say common factors are 1, common factors is 1. Okay, so highest common factor, when nothing is common, 1 is the highest common factor. Okay, let's solve the last question for the day. I want you to solve it yourself. Find HCF for 15, 20 and 25. 15, 20 and 25. Let's solve it. Solve it by your own. So highest common factor for 15, 20 and 25 is 5. Right? That's it for today. Thank you very much, students.